because the linearization is not the same as Newton's method. Always kind of gotten them confused. The linearization of a function is the way to approximate the value of a function using derivatives. And the general formula is y minus the original function evaluated at the point that is close by equals the derivative evaluated at that point times x minus c. And shall we go through a problem? I think I can illustrate all of this with one problem.
Yeah.
Okay. Let's say that we have a function f of x that's equal to 1 plus sine x. Okay? And I want to know what the value of my function is when I get x's close to 0. I know what the value of my function is when x is 0. It's 0, right?
Right.
But what if when x is 1 or 1/2 or, in radians? Remember that all trig functions are in radians in calculus. Then how can I estimate that? Well, it's hard to do. I wouldn't know where to begin, but here's a method that you can use that is very straightforward and gives you a polynomial. So, first of all, what we're going to need is, over here on the left, what is f prime of x?
Cosine of x.
And what is f prime evaluated at the point we're going to evaluate this at is 0, 1. I left that out, sorry. In other words, we want to evaluate values of x that are close to this point. This method only works if you're really close to the point. If I'm trying to figure out what f of 10 would be, I'm not going to get a real good approximation using this technique. But if I'm trying to figure out what f of 0.1 is, this technique's going to work really well. So as long as I'm close to this point right there, the x value, okay? So I want to figure out what f prime of 0 is. For starters,
would that be 0 and 2 pi?
well, this is f prime of x. So when I plug in 0 for x, what's the cosine of 0? 1.
1.
Okay. So now I'm ready to do this. Going down here, I've got y minus, well, let's see, what's f of 0? We need f of 0 also because we need f of c. What's f of 0? Here's our function, 1 plus sine x. What's it equal to?
1.
Okay. So I've got y minus f of c, which is 1, equals f prime of 0, which is also 1, times x minus 0. And this turns into, quite easily, x plus 1. So there's the way to approximate. In other words, if I want to know what the sine of, if I want to figure out what f of 0.1 is, and I don't have a calculator, so I don't know how to figure out what the sine of 0.1 is, I can use this approximation, and f of 0.1 is going to be 1.1. And that ends up being a really good approximation as long as we're very close to 0. If we get real far away from 0, then it doesn't work very well. But that's what the linear approximation of a function is. Now, do you have a specific problem that they need you to do?
Yes.
Good. Because this was just an example out of my book, but I thought that it explained it really well, so I wanted to do that. So hold on, let me leave that there, because this is our general formula. We're always going to need that. Okay, what's their problem?
It is 6 over x squared.
6 over x squared?
Yes.
Okay, so f of x is 6 over x squared. Okay.
And the points are 2 and 3 over 2.
I'm sorry, I didn't hear the last of it. 6 over x squared, what?
And then the point that they want us to find on is 2 comma 3 over 2.
Okay. So it's points close to 2.
Yes.
Notice that when we plug in 2, we get 3 over 2. In other words, that's x, that's f of x. Okay? It's the 2 that's our key point. In fact, we are not ever going to even use 3 over 2, I don't think. So let's fill in these things over here on the left. First of all, tell me what f prime of x is.
So it would be a negative 6 times 2x over x to the fourth.
Here's the way we're going to do it. First of all, that's going to be written like this, with a negative exponent. We're not going to be using the quotient rule. Never use the quotient rule if you don't have to.
Okay.
And notice that if I write this with a negative exponent, I can use the power rule. That's minus 12 times x to the minus 3, which is minus 12 over x to the positive 3. So that's the first derivative. Using the power rule, converting a quotient rule to a negative exponent. Okay, now we're going to evaluate it. We need f prime of 2, and we also need f of 2. So tell me what f of 2 is.
3 over 2.
And tell me what f prime of 2 is.
Negative. Negative 3 over 2.
All right. Okay, now I think we have everything, don't we? In other words, in our general formula, c is 2. So we know what f of 2 is, we know what f prime of 2 is, and we know what c is. It's 2. So we're ready to write it. So tell me what to write. Y minus
12 over
I didn't hear you.
y
Y minus what?
minus 12 over x cubed.
No. Here's what we're doing. Is y minus f of c. And c is 2 in this case. Let's just go over here and say c equals 2.
Okay.
So the function that we're really going to be substituting in is y minus f of 2 equals f prime of 2 times x minus 2. In other words, is all I'm doing is substituting their x value that they gave us in for c.
Okay.
Okay, and then over here on the left, we've figured out what all these things are. So what's f of 2 over here on the left?
3/2.
Yeah, I'm plugging into that right there. So 3/2 equals, what's f prime of 2?
-3/2.
And finally, we got x minus 2. And that is going to be an approximation for this thing. Now, if I distribute this, what do I get? Let's see, I get minus 3/2 x plus 3. And then I move the 3/2 over, so I get plus 4.5, which is 9/2. So there's my final answer. And let's check it. First of all, and the way we're going to check it is we're going to check values close to 2. Tell me what f of 2.1 is, even if you have to use your calculator. Tell me what it is.
Okay.
6 over 2.1 squared.
1.36.
What is it?
1.36.
Okay. And now let's go down and test our approximation when x is 2.1. Well, when I put in 2.1 here, what do I get? What's minus 3/2 times 2.1? And then add to it 4.5.
Uh, 6.1.
Well, first of all, multiply minus 3/2 times 2.1. What's that?
-3.15.
Now add to that number 4.5, which is 9/2.
1.35.
Look at how close our approximation is to the correct answer. We got 1.35 compared to 1.36. Now, in this particular problem, I don't see the great benefit of doing it because I can figure out those numbers on my own just using math and arithmetic.
Yeah.
It is a simpler, in other words, if you do look at our approximate function, it's linear, doesn't involve squaring anything. So it's a little easier to do the math on our approximate method. But this is not like the first one I gave you, which had sine involved. In other words, if I said to you, what is the sine of 0.3, there's no way to do the math on that. I don't know what that is. I'd need a calculator. But if I use a linearization, or also called a tangent line approximation, it's the same word or the same concept, then I can figure out what sine of certain values are. Excuse me. And so that's the advantage of it. There are certain kinds of functions that it's hard to figure out what f of x is given a certain x. But using this method always gives you a way of solving for it fairly accurately.
Yeah.
What else do you have?
Um.
Let me, I'm going to rewrite. I'm going to leave, I don't want to have to rewrite everything, so just give me the function and the points.
Okay, so you can do sine of x as the
Sorry.
function.
F of x is what?
Is sine of x.
Sine of x. Just that?
Yes.
Okay, about what point? 0, comma 0?
2 comma sine 2.
You see why the y value is sine 2?
I think so.
Well, if I look at my function, what's f of 2?
Sine 2.
That's f of 2. In other words, when x is 2, then f of x is sine 2. So this second value they give you, you can always figure it out. Okay, so now let's go over here on the left and figure out our various, hold on, before we do that, let's go in order. In other words, this ends up being the same, doesn't it?
Yeah.
When I go from there to there, C is once again 2. So it's y minus f of 2 equals f prime of 2 times x minus 2. Okay, so what's first of all f of prime of x?
Cosine of x.
What's f prime of 2?
Cosine of 2.
Yep, that's all you do. Whenever you have something in the parentheses, whatever it is, whether it's a number or a function, whatever it is gets plugged in for x whenever you come across x.
Okay.
What's f of 2?
Sine of 2.
Okay. Now give me this formula right there.
Y minus sine 2 equals cosine 2 times x minus 2.
That's the way you do it. In other words, this is a particular form of a calculus problem where you don't really need to understand what you're doing. You just need to memorize the method. And you can see that this is going to work with any function. Okay? Doesn't matter what it is, as long as you use this method, starting with the general formula, and then substituting for C, whatever the x value that they give you, so that you get to this line right here, and then go over here on the left and figure out all of these three things, and then plug it in to that second row. And I don't have a foggiest idea why I'm doing it. I mean, I do, but you don't have to have it.
Okay.
You just have to know the method of doing it. And this is how you do it. We don't even know what it means. I mean, we kind of do. This is actually just the beginning of infinite series, and you can actually approximate the sine function by a polynomial that ends up being 1 plus x over 2 minus x squared over 6 plus, it goes on forever. And the number of terms you use gives you your degree of accuracy. But these first two terms are what we're looking at, basically. In other words, this tangent line approximation, or what they call the linearization of a function, is really just the beginning of the infinite series process, which is kind of interesting. That's a super difficult part of calculus. You may or may not get to it. It's Calc C, basically. But that's where you run into this thing again, only in a much more complex form. Now, is this our final function? Because that's a little problematic. problematic because I don't know how to do these. In other words, who knows what the sine of 2 is? Or the cosine of 2 times whatever value of x you're going to check on. So I don't know. I'm not quite sure why that is something that we can't really test in terms of saying, well, what's the sine of 2.1? Okay. Well, this doesn't help. I don't know what the cosine of 2 times 0.1 is. So I'm not sure how this helps for that. But I'm quite certain that this, maybe quite was a bit strong, but I'm relatively certain this was the right way to go. Do you have answers on these? This one particularly?
I might.
I don't feel like this is right. I feel like I'm doing something wrong here. What could it be? You sure the point they gave you? Yeah, 2 comma sine 2.
Yeah, he has y minus sine 2 equals cosine 2 times x minus 2.
Yeah, that's a multiplication going on there. X minus 2. So that is the answer they gave?
Yeah.
Okay. Doesn't seem like that's terribly helpful, does it?
No.
Oh, maybe it is. I guess it is, now that I think about it. Now that I think about it. In other words, if we know what sine 2 is, and we know what cosine 2 is, those are just numbers. Sine 2 is a number, so is cosine 2. And this will allow us to take whatever sine 2 is equal to, we'll call it a number, and it's equal to another number, times, and now 2.1 minus 2 would be 0.1. So I turn everything into a polynomial. In other words, that's the beauty of this method. I just didn't see it when I first looked at it. And that is, you take something that you don't really have a way of doing manually, and you turn it into something that can be done with a polynomial. Even though you'd have to know what the sine of 2 and the cosine of 2 are, still most of the variable, all of the variable, turns up being in that x minus 2 right there.
Okay.
All right. But the key is just follow that pattern. Everything you see on this page, just do it exactly the same steps as I went through one by one.
Gotcha.
Okay? All right, Brianna, I'm glad I got to finish your session. Gosh, I wasn't sure I was going to get to do anybody tonight.
Yeah, I'm glad.
Losing your internet's like losing your phone or having your computer go down.
It's the worst, yeah.
That's the situation, yeah. Right.
Yeah.
Have a good one. I'll talk to you next time.
Thank you.
Bye-bye.
Bye-bye.